ringing alarm, orbiting energy, or a stylized fire. These stunning VFX might all look like pure magic and art, but here's a secret. There's math behind all of these. Yes, you heard that right. Especially if you want to work in the gaming industry, math is the basis of how we do so many of that cool stuff. I'm an ex-software engineer that became a VFX artist in games, so trust me when I tell you this. A little understanding of math plus your artistic skills will become your superpower and make you stand out from the crowd. Today's topic is trigonometry. Yes, that sine and cosine stuff that you learned in school. Something you probably heard of but never really fully understand. So stick around and let me show you how these actually work. I'll be showing you some examples of how I use them in a real game, so it'll be much more interesting than what you learned from school, I promise. So, sine and cosine, what exactly does that mean? It's actually much simpler than what you might think. By definition, given an angle of theta on a right triangle, the sine is the ratio between the opposite side of the triangle to the longest side of the triangle. For example, let's look at a triangle where theta is 30 degrees. The longest side is 2, the opposite side is 1, and the adjacent side here is the square root of 3. So by definition, sine 30 degrees equals 1 over 2, and cosine 30 degrees is square root of 3 over 2. But how is this helpful in making games? Well, that's where the graph comes in handy. To make a graph of a function, we can calculate every output of sine given an angle theta, and we treat this as a coordinate on a 2D plane. Once we have enough dots, we can just connect, and that is a graph of a sine function. Or we can just type in sine x in Google, much faster. But anyways, what it gives us is this beautiful wave-like graph, which is why we often call this a sine wave. Now let's see some example that uses this sine wave. The first one will be giving our light bulb a periodic glow. I have this lamp mesh here that I want to start ringing red lights when it's triggered. But how can we do that? Here's where the sine waves comes in. One of the characteristics of the sine wave is that you can see that its value pattern just keeps repeating and goes up and down in the 1 to -1 range. This is what we call a periodic function. And that's exactly how we're going to control our material to add a pulsing glow to it. We can take a sine wave and sample its value at 0. Then we start making the sine wave to move, and you can see our sampled value begins to bounce back and forth between 1 and -1. We can then use this value to change the light's color so that when its value is 1, it glows red, and when it's -1, it returns to its original color. With the sine wave moving so fast here, it creates that alarm effect that we're going for. But there's even more usage to this in games. Previously, we applied it to the emissive value, but what if we apply it to the world position offset? Now what world position offset is basically just how materials can move vertices around on a mesh. So when we apply a sine wave on a regular rectangle mesh, we can turn this into this. Now this might not be obvious of how we can use this in games, so let me show you an example. Here's a fire VFX I made that is rendering on the previous rectangle mesh. Now what will it look like if we apply that wave motion to it now? You can see that we get a more lively fire, something that feels like it's getting blown by the wind. And although this is just a subtle change, it is what makes a big difference in your final work. One last thing that I like to mention is an interesting way to understand sine and cosine, and that is to use a circle with a radius of 1. Now, for any point on this circle, how can we find its coordinates x and y? We actually already know that. That is because when we connect the point to the center of the circle, we can create a right triangle. And since our radius is 1, we know that these two sides will be exactly cosine theta and sine theta. Therefore, when we want to rotate a point around a circle, we can just use cosine sine as its coordinates and just increase theta over time. I made this little animation to show you the relation between sine and cosine to a circle. The blue curve here is sine and the orange curve here is cosine. When I lock the green diamond's x coordinate to cosine and y coordinate to sine, you can see that it starts to move in a perfect circle. Pretty cool, right? But again, how can we use this in games? One common usage is to make something orbit. If we directly set a particle's position as cosine, sine, and 0 in a 3D space, and you can make them rotate around a point as you increase theta over time. Now, with some extra sauce, we can create something like this. It could work as some orbiting energy or some kind of shield magic in your games. That's about it for today's video. I hope that you learned a thing or two about math, or at least get more interested in math because it can make so many cool things in games. If you're interested in this kind of topics, I have so many more videos in my channel that goes deeper on this topic, so like and subscribe if you enjoy this kind of content. I appreciate your time, and I'll see you in the next one.